Okay, for inequalities, there's a little bit trickier part you have to remember. So over to the right here where it says important, remember when you must flip the inequality signs. Remember that from inequality, just regular inequalities. So if you had negative 3x is greater than 12, when you divide both sides by that negative 3, notice to begin with, this side was negative, this side was positive, but when you divide both sides by a negative divide, this side is now positive, this side is now negative, these two signs flipped, so that the inequality sign needs to flip. So that's one of the things that you need to remember. The other thing that you need to remember is that anytime you see the word inequality, it indicates shading. You need to remember to shade the graph. Okay, so the solving is similar in that you isolate for the absolute value bars. So you would multiply both sides by 5. And then remember that this is saying that the distance from 0 is 15. So if you look at a number line, there's negative 15 and there's positive 15. So you remove the absolute value bars, so negative 9n. We're writing it exactly as it is, but remember, when we give the negative version, negative 15, well, negative number, that is flipped. So you must remember to flip that inequality sign. And then go ahead and write negative 9n. And then, so you have that set up. And now, be careful. When you divide both sides by negative 9, what did we just do again? We divided an inequality by negative. This now flips to positive n. This now flips to, they both have a 3 in common, so negative 5/3. Because both sides flipped, we have to flip this inequality sign. We're going to do the same thing over here. This now is positive. This now is also positive, so positive 5/3. So we have to flip that inequality. So, and then we're going to shade. N is greater than negative 5/3. N is less than positive 5/3. Well, positive 5/3 is another way of saying 1.6 repeating, negative 1. Just to make it easy for you to figure out. So negative 1.66. So maybe there's no solid bar. So we'd either put hollow dots, or you could put an open parentheses for later on when you have to show interval notation with open parentheses or solid brackets. So n would be all the values greater than negative 1.6666. So right about there. Now I'm going to go in that direction. And then n would be all the values less than 1.66. And where those two things overlap, remember, it's not including the brackets. So that's why they have to be open parentheses, or you could put a hollow dot. But this would be the solution set right there. All right, so let's go to the next page. Now I'm going to give you just the overview of when you've got specific situations. If you're given a situation where you have an absolute value is less than a negative number, well, remember, this says absolute value means distance from 0. Well, can you have a negative distance? No. That would be always a no solution. So on this one right here, even if we add 7 to both sides, we're still going to have, oh, I'm sorry, I should have paused this. All right. Well, I could have left that. When you have absolute value is greater than a negative number, well, if distance from 0 is always positive, is a positive number always greater than a negative number? So all positive or all reals would be a way to say that. So when you have an absolute value said greater than a negative number, the answer is going to be all reals. And one way to write that would be negative infinity to positive infinity. Then, so let me go ahead and change this over here. When you've got distance from 0 is less than a negative number, well, that can't be. A distance can't be negative, so that would be no solution. So if we subtracted 7 both sides, we would have the absolute value is less than or equal to a negative number. Well, a positive value cannot be less than a negative. So no solution. All right, that's it for this one.